Hello and welcome to tonight's safety seminar on cold weather flying. Uh, if you're just joining us right now, we're going to give it a minute for those who are entering the room. Please do go over to the chat, introduce yourself, tell us where you're flying these days or where you are tonight. And we do have a fairly busy schedule, so oh, you know what? Let me just move everyone's heads around so you could see a little better, but tonight we will have, there we go. Tonight we'll have a presentation from ForeFlight. We have Adrian Tegler with us here today, and there'll be some great updates on some of the features that they have and promotions. Then we have a presentation from one of our other program sponsors, Tennis Aircraft Products, with Doug Evank. He'll go over aircraft preheating. Hey, Doug. And then we'll take a quick break because there is quite a bit going on tonight. So we'll take a short break and then we'll jump back in with Chris Horston over at Sport Aircraft Canada to go over some considerations for Rotax preheating. And then we'll close it up with Ronan Court here, who is one of our COPA members on search and rescue awareness considerations. And with that, it does qualify, or tonight does qualify for recurrent training. So log the details that you see on your screen into your logbook. I will put it in the chat as well, so no worries if you aren't able to write as fast as I am speaking. I'll put it in the chat. We do send out a certificate that you can keep for your own record keeping, but it is these details on the screen that are the most important to keep in your logbook itself. I am also sharing with you that this is the last safety seminar of the year, and we have been providing an annual draw each year. Well, this is the second year. Due to timing, I will draw the name at the end of the seminar, tease you a little bit of what you might win. So the first prize is a Lost Aviator coffee pack, as well, and a Zulu 3 headset from Lightspeed, a SiriusXM Pilot Pro package, and then a COPA membership renewal. Second place, we have a SiriusXM package and then a COPA membership renewal. So it's a pretty fantastic offering, if I do say so myself, and hopefully we'll be able to keep you around so you can see the winner. We do put in anyone who's attended our safety seminars, or COPA members who've attended our safety seminars over the last year, anyone who engages in the chat or in some form, and every bit of participation does get you a ballot in that draw. With that, let's get started. I do have with me here today, oh, there you go. You see a full house. I do have with me here today, Adrian. So why don't I ask you to introduce yourself, Adrian, and start your presentation.
Yeah, for sure. Thanks, Sharon. And hello, everybody. Thanks so much for having me. It's great to be here again. And so I'm just going to do a quick screen share there. Hopefully you can see that okay. I'm going to do a quick little talk on ForeFlight. And so let's jump into it. So as Sharon introduced, my name is Adrian Tegler, and I'm a member of ForeFlight's pilot support team. I'm also a fellow Canadian pilot, so it's great to be here. So today's topics, we're going to look at, just do a quick new feature highlight, take a look at that. And then since a good portion of the seminar later on is going to be about search and rescue, I wanted to make this ForeFlight talk applicable and talk about some of the search and rescue tools that are built right into ForeFlight. And so we'll do that, and then we'll connect in and look at content packs. That could be helpful for search and rescue and for all aspects of all different aspects in ForeFlight. And then if we have time, we'll quickly look at a couple additional tools, and then we'll end with some Q&A. All right, so let's take a look at the new feature for this evening. I thought this one was applicable to, could be applicable to search and rescue. So custom waypoint elevations is something that's new to ForeFlight. So now you have the option to specify an elevation for any waypoint that you create in ForeFlight. And why is that useful? Well, this actually allows you now to plan routes to and from these waypoints and ForeFlight will calculate accurately your climb and cruise and descent profiles, just like it would if you were planning to and from an airport. So this can be really great if you're landing somewhere that's not an official airport, whether that's on water or a grass strip somewhere that's not registered, anywhere. So that can be great for more accurate planning. And that can be done right in ForeFlight, adding the elevation like you can see in the screenshot. It can also be done in bulk if you're importing waypoints in bulk in part of a content pack. For example, you can associate elevations with them and they'll all be part of the waypoint. All right, so let's take a look at some search and rescue tools that are built into ForeFlight. So I'm going to quickly go through some of the search and rescue patterns that you can preload in ForeFlight. I'm not going to go into these in really intense detail, just we don't have the time to do that this evening. But just to give you a sense of what you can load, I wanted to quickly kind of go through the different patterns. Now, first of all, to get this option, you want to make sure that you go into your ForeFlight settings and there's an option to have search and rescue. So go down and make sure that's enabled. And once it is, you can go to the maps page, like in this view, and you can tap on the procedure button, which is at the top right of the maps page when the FPL menu is in view. And you can have the option to select different search and rescue patterns. So we'll go through them now. The first one is a circle pattern. And you can see as we go through each of these, there are different options that you can do to build the pattern to suit your needs. So here I've got circle selected. You select the waypoint that it's associated with, and you can add a radius. And once you tap add to route, it's going to plan that right on the map. You can do a creeping line pattern. You can see there's some more options here in terms of the initial direct track, initial turns, leg length, spacing, number of legs. So there's quite a few different options to make this work to suit your mission. Expanding square. A parallel pattern. You can do a route search. This is nice you can enter any type of a route, whether that's waypoints or airports or lat-long coordinates. And then you can add the spacing that you want and how many passes, and ForeFlight will plan a route search based on whatever route you'd like. A sector pattern. And that's just the kind of the broad overview of some of the patterns, that search and rescue patterns that you can quickly load in ForeFlight. To learn a whole lot more about this, one, it's nice just to play with this feature in ForeFlight on your iPad or on your iPhone. Load the patterns, add different tracks or headings or routes or waypoints to kind of see how it works. It has a whole bunch of different uses. Even if you're not flying actual search and rescue, it can be a unique kind of feature to play with. There's a great guide, so you can bring up the guide right in ForeFlight. Documents, ForeFlight, on the documents page, and then look for the search and rescue guide right in there. Anybody who doesn't have ForeFlight, you can always download it for free from the App Store. It automatically includes a 30-day trial, so you can take a look at these features too, even if you're not using it actively right now. All right, so let's get into content packs. So what are content packs? Basically, content packs is quite a powerful tool that allows you to import and display and use quite a broad range of custom content right in ForeFlight. So this can include custom charts like this. We've got a BC topo chart, georeferenced, imported right into ForeFlight. You can plan your routes with it, zoom in and out. Map layers. So here's an example of some custom map layers. You can use these layers to highlight, anything from a practice area to a restricted area that you want to highlight even more than what's shown on the map, to areas where you might want to search if you're doing a search and rescue type of a mission. And you can create these and import them into ForeFlight. And it's actually surprisingly simple with tools these days, like using Google Earth or Google My Maps to create different layers and save them as a KML or KMZ file that can be then imported into ForeFlight. Here's another example. I thought this was cool. This was a recent content pack that was created by actually a fellow Canadian ForeFlighter, David Harris, did this, and he created a content pack that captured all the power lines in France. And it just shows you how powerful this tool is. And we can zoom in. So if you zoom in, there's like the close up on that view of France for pilots that are flying low level, so helicopter pilots or search and rescue pilots. It was just crucial to have this information. And he created this amazing content pack that shows all the power lines. And it's an option to overlay it on the map. So you can turn it on or off, which is great. That's a nice thing about these features is you can show them when you need them, and then you can hide them when you're done if you don't want to see it. All right, so I think we've got just a couple more minutes before we get into Q&A, so that's perfect. I'm going to take a look at just a couple more tools. So one that's often used in search and rescue are marked positions. So this allows you to drop markers during a flight to note points of interest or to comply with position plotting requirements. And you can drop these points or these marked positions at any time, and they're going to capture your GPS lat long at the time that you dropped it. They're going to capture the altitude and the speed at that exact point in time during the flight. So here's an example of a search and rescue route along a river. And then there's points A1, A2, A3 that you've dropped. And you can either just tap one button to drop it, and you don't have to do anything else. You don't have to add a name until after the flight. So it's quick and easy to do, but it captures all that information. If you have the time, you can add a name and you can add notes to it, or you could do that after the flight. But this is a great tool. And it shows up in your track log. If you've recorded a track log of your flight, you can share this information. These waypoints are retained for future use if you need to use them again. This is just note on this one. If you haven't seen this feature, this is a performance feature in ForeFlight. So Performance Plus subscription for this one, just to note that. Another one that I've used for ages, back when I was doing my initial pilot training, I was using one of the very first versions of ForeFlight, and this I think has been around since the start, and it's still a great tool today. And this is where you can enter waypoint radial distance in ForeFlight, and so you can do this from any point. It can be from an airport, it can be from a VOR. It can be from a lat long coordinate, a user waypoint that you create. So it can be from anything. You just, the waypoint name with a slash, the radial. So in this case, it's 060, and then the distance, so 17 miles. So you can just adjust that to your needs and make that waypoint radial distance. And ForeFlight will plot that on the map. And then taking that a step further, you can also plot the intersection between two radios. So in this case, if you want to say, okay, where does my point is alpha? So alpha on 080 degrees, where does that cross my other waypoint Bravo on the 020 degree heading? So if you just put that in with the first waypoint, the radial, the second waypoint, the radial, ForeFlight's going to plot the intersection point for you, which is kind of handy if you're looking at doing an intersection. All right, I think we're right about at our time. So we will quickly jump into a little bit of Q&A here.
Adrian, you're a crowd favorite. The chat is just bursting with how much people enjoy the update that you've given. I think it's because not many people are familiar with the search and rescue functionalities. So it's less questions. Well, a few technical ones of how to access the menu for the pattern that you had shared. I don't know if you can share that again, or just describe it.
I don't Oh, the menu. Yeah. Okay. Let's just go back a few slides, see if I can just jump quickly here. Mhm. Okay, so yeah, my screenshot there, it's kind of hidden. So if you're on the maps page, first of all, hopefully it looks like it's okay. But it looked like it was catching up with itself. But if you're on the maps page in ForeFlight, first of all, you want to make sure that you have the FPL menu, the flight plan menu open, which is that highlighted in blue at the top. So you tap that, drops down the flight planning menu, and then it's kind of hidden in this screenshot, but the top right corner, there's a button that says procedure. So you tap on procedure, and if as long as your settings have search and rescue enabled, you'll see search and rescue as an option in there. So if you don't, go more settings, and either you can just search SAR and it'll show you where that setting is, or you can scroll down in the list until you see search and rescue and just make sure that that's enabled, and then you can start adding patterns right from there. And that should be available in all subscriptions before all
Okay.
levels.
Awesome. Thank you for that. We don't have a ton of time for many questions, so if you have more for Adrian, put them in the chat. What I'll do is I'll take them all down and send them over to the ForeFlight team, and they'll get back to you directly. There was one last question on pushing the panels. Can you push those paths to your panel GPS? Do you have the answer
Yep.
for that?
So that's a great question. Yes, this should work. So there's a couple options here. You can have in the settings again. So more settings for flight to have search and rescue patterns be created by lat long waypoints. So that means when you put that on the map, there's a whole bunch of little lat longs that build that circle, for example, or build that expanding square, or whatever you do. So as long as it's in a lat long format, you should be able to send it to the panel, and most panels will accept it if you have a setup to send from your iPad and ForeFlight to a panel, like a flight stream setup or something. Where sometimes it gets tricky, if you have a lot of waypoints that are really, really close together, some panels won't acknowledge that. They won't see the separation. So but in most cases, the short answer is yes, that'll work. And if you have any issues with it, definitely just email team@foreflight.com and we can help you get it going, because it can work to send that to your panel.
Okay. Well, thank you so much, Adrian. Like I said, lots of good comments in the chat. So appreciate your time with us here today and ForeFlight support of the safety seminars we put together.
Thanks so much for having me, and I'll stay and answer questions in the chat. And yeah, thanks again. Take care.
Awesome. Okay, so next up, we do have the main presentation for today with Doug Evank, who was Tanis Aircraft Products was actually one of the first sponsors for our program when we first started. So definitely always want to give them a shout out. So Doug, why don't I ask you to introduce yourself, and I'll pull up your slides here as you're getting into that. There we go.
Thanks, Sharon. My name is Doug Ebank. I am the president of Tanis Aircraft Products. And a little background, Tanis has been around now almost 50 years, started in the early 70s, based in the Midwest part of the United States, but originally started from the aspect of preheating small piston engines, and now actually our biggest marketplace is turbine and rotor wing. So I'm going to go through a set of air conditioning or aircraft preconditioning slides where we talk about why do you preheat, when do you preheat, what should you preheat, and then there'll be a slide that comes up that talks about questions, and I'll answer some of those. Sharon will kind of monitor them in the Q&A side of it. But a little of a travelogue to start with. Those of us that are on the panel, we're talking about Oshkosh, so the little Tanis can preheat anything that flies and some things that shouldn't, from our witch's broom in Oshkosh for our setup, all the way to we sponsor a fly-in on a lake after the ice houses have been removed. And we keep people that have stay ready all year. They have their amphibs and go ahead and land on the lake. Tanis Aircraft Products, I purchased the company in 2012, and in June of 2021, sold it to Hartzell Aviation. But the headquarters will still be and is currently in Blaine, Minnesota, which is a northern suburb of the Twin Cities, just northern Reliever Airport. And that's this office where our sales and engineering is at. And for the last 40 years, the manufacturing site has been in a town called Glenwood, Minnesota, which is in west central Minnesota. And that's where we manufacture all of our product. That will soon be moving over to Piqua, Ohio, along with the Hartzell heated products. As I mentioned, Hartzell Aviation, family of brands, just picked up another Canadian company, Acorn Welding. But this is some of the brand names that you'll hear. Obviously, Hartzell Propeller, been around for over 100 years. Ourselves, aerospace, welding, manufacturing, Hartzell Engine Tech, Janitrol, those are the names that are part of it. So what is preheat weather? We get that question so often of, well, when should I start preheating? What temperature should I start preheating at? So the first couple slides here is kind of a dialogue of and a travel log, really, of whether it be at our airport in Glenwood when it's minus 36 degrees, that's definitely preheat weather. Whether you're on a glacier up in Alaska with sled dogs, that's definitely preheat weather. We go to the Alaska Airmen Show in May, and this is what it looks like in Alaska in May with snow still around, 10 feet of it over at Hatcher Pass on May 5th. When there's snow around, we know that you should be preheating. But really, the aircraft engine manufacturers for the longest time have stated that once your engine is, this is saying 20 degrees Fahrenheit, once that engine temperature falls into that range, you must preheat. We have found that there are a lot of advantages once you start seeing single digit weather, anything below 10 degrees C, 5 degrees C, we have a lot of advantages. But this is once you're seeing below zero, yes, on the centigrade side, you're definitely wanting to preheat. They had information bulletins out. They also talked about the right way to preheat by using cylinder head, heating the cylinders along with the oil. Why you should preheat, because the oil will congeal, the battery capacity is lower, things like that. So we've really been publishing and putting out, and for those that were on this last year, these are the same main goals of preheating. This is what we talk about at every presentation. The main reason you do that is to reduce the wear of the engine. The makeup of our engine is all different metals, expanding at different rates. When they get to that freezing or below temperature, when they heat up, they expand at a much different rate once the combustion process is in place. And if you haven't preheated that engine, you are going to run across issues where you do not have the oil flow. You may have oil pressure, but not oil flow. For a long time, our batteries were forward of the firewall. Now many of us have batteries that are after the firewall. So why do we preheat? We want to make sure we get full battery use. So we actually have battery heating elements also now to make sure the battery is ready to start that engine. Obviously the ease of starting, but it isn't just starting the engine, because sometimes the worst thing you can do when you have a cold engine is get it started if you haven't done a thorough job of preheating, because that's when it will do that damage. We're also seeing a lot of requirements that certain temperatures have to be met before they can lift off. Accessory gearboxes, prop reduction gearboxes, the radials, the oil have to be at a certain temp before we fly. So that's another reason why we preheat. The biggest thing that happens when we do not preheat is the cylinder, the top of our cylinders are actually smaller in diameter than the bottom. And that taper is really the reason why we want that cylinder heated along with the oil. Obviously, we want the proper oil flow now with our product going across the whole bandwidth of turbines and larger engines. We're now talking about the whole critical driveline components, such as in helicopters when we're looking at gearboxes and accessory gearboxes, tail rotor gearboxes, things like that. And you really, I said there's 10 of them. We tagline is aviation safety starts with TANUS. We want to make sure that you can safely start and fly that aircraft during that time. And number 11, as you've seen earlier, the engine manufacturers do mandate preheating at a certain temperature. So here's a goal that TANUS has had for a long time. And when I got involved with our team, we really tried to get this message out into the public of why it's so important to not only preheat, but preheat in a prescribed manner. And that being, we want to get the cylinder head above ambient a certain amount, and you'll hear me talk about a little bit more. If you need more than 30 degrees C's above ambient, there's ways of doing that. But that's our goal when we develop a system. We want to make sure we get the cylinders at least 30 degrees above what that ambient temperature is, and we want to make sure the oil is at least 20 degrees above ambient. But we don't like seeing the oil getting anywhere near 49, 50 or above degrees C because of the pad or the element or whatever we're using to heat up that sump obviously is much smaller than the mass that's there. So it has to be so much hotter than the oil to get to that temperature. And if you start getting into that area, you're going to possibly break down the oil or even coke the oil into the inside of your sump. And the big part that we constantly talk about is think about dew point and condensation. Whenever we fly and when we stop that engine, inside the crankcase, that engine is made up of basically whatever temperature we're flying at, whatever temperature our oil is. It's 100% relative humidity above that oil line because there's so much blow by in the combustion process. And eddy water is going to condense on your oil. So when you start preheating, or even when you're not preheating, that water is going to evaporate. It sits on the oil, goes down, water's heavier than the oil, so it goes down to the bottom of your sump. It'll start evaporating. And when we plug something in, whether it be any type of heater or even our heater, you are going to accelerate that rate of evaporation because the evaporation is the difference between the temperature of the water, or in our piston engines, the temperature of the oil, and the ambient dew point in that crankcase. And I always try to break it down into, think about a cloth, a washcloth or a towel that you've left out in the middle of the summertime when it's hot and humid. It can stay wet for a couple of days. But in the wintertime, when we're using heat to warm up our homes, it'll evaporate so much quicker because that delta is so large between one and the other. So what we have done is we have developed a multi-point preheat system that keeps every cylinder and all of the parts of your engine that are from the oil line and above warmer than the rest of that oil. So basically any moisture that would come up out of the sump or out of the oil, it's evaporating and it will not condense on anything that is above the dew point. The item has to be colder than the dew point in order for it to condense. And that's really the key of why we've designed our multi-point preheat system in such a way that we can leave that system plugged in all the time because we want to keep everything warmer than the oil. And you'll see me talk about this and see some graphs here in a bit, where once you start preheating, we want you to fly, or we want you to keep that preheater on until you fly. And here's some of the things that you can do to confirm the same type of results and same type of tests that we do and that we use to engineer our product. And this is kind of when I threw this in. Some people, thinking about dew point, we have dew point meters that we put inside of the crankcase. And when we preheat, you see the large difference between when that TANUS preheat system was turned on to when it was turned off. We gained another 40 degrees Fahrenheit of safety room, I'm going to call it, between the dew point inside that crankcase and the temperature inside that crankcase. But if you have a Cirrus and you have a cockpit like this, or if you have an engine monitor that gives you and reads out your cylinder head temperatures, let me go back to that one. This is one way you can find out A, if your preheat system is working, and B, if it's working the way you want that to work, because you can snap the masters on, take a look at your engine monitor, and you want to see those CHT temperatures warmer than your oil. Now, granted, wherever your oil sensor is at may not necessarily be in the sump of the oil, so be thinking about where that's at, but you do want to see your cylinder head temperatures obviously above the ambient temperature and much warmer than the oil, so you have that safety spot. And then you also get to the next thing of how warm do I really want those cylinders to be. We use calibrated data loggers to do all our testing and prove out the effectiveness of our system. And what that looks like is we take thermocouples and put them right touching to the cylinder sleeve on the opposite side of wherever we're heating, so that we're measuring the temperature of that cylinder. We will put one or two thermocouples into the oil, into the ambient temperature, so we can do a comparison. And this is us doing a temperature map on an aircraft, bundling it back up, putting it at the engine cover, basically using it, doing a mapping the same way that you're using that aircraft. And when we're done with that, we get a chart that gives us the data that we can look at to make sure we're getting the job done the way we want to do that. So you see here, this happens to be on a Cub Crafter. I have the other one here a little bit later, but you'll see how very quickly within the first hour and a half to 2 hours, we're gaining that 30-degree rise above ambient, 20-degree rise for the oil above ambient. The green line is your oil, because there's more mass there, more oil, so the oil takes longer to warm up. Inversely, when it cools down, it takes longer to cool down also. But we really want you to see that gap between the oil and your cylinders. And then based on your ambient temperature, you can decide if you have to add the insulated engine covers or anything else to add to that thread. So here's a 172. People ask us, how is it that you can leave this plugged in and it just doesn't keep on getting tremendously hot? Well, we develop the wattage, the elements that we put in, we make so that it matches the mass that we're heating. And after a period of time, it just rides that ambient curve. So you'll see in this slide where we start out at -8 degrees and it dropped down to -12. Well, you see up on the top, our cylinders and our oil did the same thing. We're riding that ambient curve. And this particular one, we were testing out our avionics cabin heater at that time to give us some feedback on that. So that's really the key of what we want to see. But then, depending on where you're at, you may say, well, geez, great, it's -20 when I'm starting, or -25, and I need more than that 20 or 30 degrees of temperature rise. What do I do? So here's an example of a Cardinal 177 where first you have the rise in temperature above ambient with just the preheat system, and then you added the insulated cover. Now with the insulated cover, it takes a much longer period of time. So now you're talking about at least leaving it plugged in or starting it the night before, or 5, 6, 7 hours before, in order to get that temperature rise, where an hour and a half to 2 hours with just our system, you get that rapid rise. It takes much longer because now you're relying upon that insulating value of that insulated blanket to add that temperature. Don't forget about cowl plugs. Here was a case where we were mapping for a flight school, and they tuck the aircraft in a big hangar, and the hangar door is open until about 7 o'clock that night. And what they found is just in a mild day, probably a 10 knot, 15 knot wind, just the air circulating in and out of the cowl openings of our aircraft. That's how much difference the temperature of those cylinders will be just by that cooling effect. Once they close the hangar door, boom, the temperature rises, and then we can start the more steady rise of the temperature. So a set of cowl plugs, if you don't have room to keep an insulated engine cover with you, can really add to the effectiveness of trapping the heat inside the engine, or even adding to the amount of temperature rise that you can have. One of the questions we always get is, hey, I use a sump only. I heat up just the oil, and if I have an insulated engine blanket like this one here, and I've got it tucked in there good, eventually everything in that engine is going to be the same temperature, isn't it? So we had a flying club that posed that to us. And the way we do is we let our engineering and let the data loggers prove this out. So we went over there, and this is what that log looks like with the sump only. You see the oil temperature was running up to above 25 degrees, where the cylinders didn't even hit 10 degrees. Unfortunately, we didn't plot the dew point line here. The dew point in that crankcase was right at about 15 degrees. So all the cylinders were getting the start of condensation of that evaporation process, condensing on the cam and condensing on the cylinder. Now, if you flew, get the oil in there, run that through, then you're doing okay. But if you don't fly, that's what sets up this whole condensation and corrosion issue. We took that system off, installed the multi-point preheat system, and now you're seeing the curve that we talked about earlier, where the cylinders are above the oil and then the ambient. And that, the other thing I want to point out, people ask, what about a prop cover? Is that effective? Is that something, if I'm not in the hangar, is that important? You see that, well, it's actually the third from the bottom line, but the brown line leading across that graph, that's the temperature of the prop. Our heat that we're producing inside that engine produced that much of a temperature rise, and the temperature 6 inches away from the hub on that prop. So when you're out on the tarmac or in an area where it's going to get cold, if you have a metal prop, really, really important to have a prop cover for that. If you have a constant speed prop, if you're doing the preheating, we don't have anything to get preheat into that oil. So before you fly, cycle that prop so that you can move some of the engine oil into that constant speed prop clutch so that you can basically warm up that whole piece. So that right here is the point where I break a bit for questions, if there are any, Sharon, or I can jump into the second portion of the presentation.
I mean, you typically get quite a few questions when you come in. So there was somebody asking for you to say more on tapered cylinders or narrower at the top.
Yeah, so if you were to take a micrometer and measure the bottom of your cylinder and then measure at the top, there's going to be a difference, and it's going to be smaller at top than it is at the bottom. And that's just part of the ease of compressing the rings inside the cylinder. That's been done for such a long time. Let's face it, the engines that we're flying, their type certificate have quite a few years on them. So there hasn't been a lot of changes in the makeup of the way that cylinder is. So if you looked at it, the bottom, I'm going to over exaggerate, the bottom would be like this, the top would get taped tighter. And that's why it's important to preheat, because that's where you'll see your damage done at the top of that cylinder.
Okay, very good. There was a question for clarification when you were referencing oil. I think that there was mention of it needing to be at least 20 above ambient, but not more than 49 degrees. And someone was asking if you meant 49 above ambient.
No. So what we have found. So let's basically say, what temperature do we as a preheating company like to see of the oil when it's not running? Because remember, obviously, we're not running the engine, so we're not going to get it up to that normal engine oil temp. We don't like seeing it in the 50s, because, and that's 50 degrees C, because the pad or the element or the probe that's getting it up to 50 degrees C is much, much, much warmer than that. And that's where the damage can be done to the oil or to the substrate that it's glued to.
Okay, hopefully that answered that question. There's a few questions on how long it should be left plugged in or prior to um, starting your operations.
So unheated hangar is where we do start the baseline because we don't know how much the wind's blowing or what you're projecting the wind inside of that. So our preheat system by itself, in that first hour and a half to 2 hours, you're going to get 85% of the max done in that. That's going to get you almost that 30 degrees rise in the cylinders, 20-degree rise in the oil. How long you need to preheat depends on where you're starting. If you're starting at 0, that hour and a half to 2 hours is fine. If you're starting at -10 or -15, most of us know what we like to see for our oil temp or for our cylinder temp before we start to fly. And that's why we also, the airplane that we fly very regularly, we plug it in. We start plugging it in October, and we unplug it in March or April, just because we're ready to roll with that from that standpoint.
Excellent. And is condensation an issue for dry sump engines?
So great question. You tend to throw a lot of things into the same pot here, but dry sump engines, condensation is not as large of an issue because that oil is in a remote reservoir. Now, on a dry sump, we still like to see the cylinders warmer than that sump, because the minute it starts, you're going to get that same type of evaporation. But no, good question. Dry sumps are not as concerning, especially in our next speaker talking about Rotax. It's a dry sump with a water jacket. It's a little bit different, but yet you still want to heat that reservoir then.
Okay, lots of love in the chat here. Maybe I'll just take 2 more questions and then we can continue on. So one being reflecting on those charts you had shared, how do they vary from flat to radial engines and the geometry of their cylinders and oil systems?
Yeah, so the charts that you've seen were Lycoming and Continental from a 320, 360 to a big bore Continental. That's the charts that we're seeing that we're putting up in there. We also have systems for radials. When we design our heating, the amount of heat we put in there, we basically try to get the exact same type of result. The only difference in that chart, and I think I've seen some of the questions in the Q&A, when you add that insulated engine cover, you get so much more. Well, the problem is on a radial engine, you don't get as much because not too many people have a insulated engine cover big enough to go around that radial engine. So you get a little bit harder time to trap that temperature inside there.
Okie dokes. And can you walk us through the installation process? Not in full detail, but generally.
Yeah, so that's the second part of the presentation I have, which I'll fly through those slides pretty quickly. I know it's being recorded, and there's may not be mechanics, may not be installers, but I'm just going to go through that group for the rest of the presentation, and then we'll take questions again at the end. So we get into, and this is really going to be TANF specific. How do you know how to install it? What is it? What makes up our system? So we basically have a couple key documents. Right now, we have one system for all 4-cylinder Lycoming, Continental, Franklin engines, one system for all 6 cylinders. And they're the exact same system, and the install obviously is a little bit different, but you'll see these documents, and you can find those documents by going to our website and just clicking in that upper right-hand corner under document search, or if you go to the website, click on piston and download the documents. You can get these from our website. All you have to do is just log in and download to them. So you can look through it and take your time reading through it versus me flying through this. But this is what our installation instruction looks like. We're going to tell you the tools required, the installation required, where to put the plug, how to run the wiring harness, where do you literally mount the plug, because we have a round plug that has to be mounted someplace. This is a circular plug bracket that we use on the long fill tube like Lycomings that you can use the self-fusing tape to glue that or glue it to fuse it around that fill tube. So it gives you this type of arrangement that looks like this once the cowl is back on. So you have an indicator light and you have a one solid place, so you can use one hand and plug it in because obviously tail draggers and more, that gets to be quite a reach for people that aren't 6'6" or taller. And you can't get two hands into that opening. We have other type of shore power plug arrangements, like flush mount plugs in the cowl opening, openings and arrangements to mount it to the Continental Sandcast or other engines. So you have a firm place to mount that plug, and our plug is literally that NEMA plug, so you can see that you are going to have a good large round circular clamping capability so that you can hold it in place. Because our number one failure, I think everyone's number one failure in the electrical preheating side of the world is breaking off or busting the wire right at that shore power plug. Here's a case of where you kind of pull it together with some cushion clamps and offset clamps. We have just about every imaginable way covered, even going into having door kits and kits that you actually start having to cut into the side of a fuselage. One thing I like showing is we talked about installation. We use threaded elements. So we have a threaded element in each cylinder and a pad element that goes on the bottom of the sump, and on the 6-cylinder, one on the bottom of the sump and one on top of the case. But this has become our favorite now because we do have a threaded element that you have to thread into either the rocker cover or an intake tube location. We sell this deep slotted socket so you can go over top of that 1/2 inch and plug it in. This is what our connector looks like now. We've been in business for quite some time, so we had male and female spade connectors for decades, but for the last 15 years we've been using the Deutschblatt connectors that have pins and sockets like this. So we would want you to take and convert your old system to make sure that they have that type of arrangement inside of it. But this is what it starts looking like. What does an install look like? This is the Cub Crafters, the 363, where you're seeing the intake tube installation. So one of the fasteners is removed, and our element, this is a stainless steel, heat-treated stainless steel body with a potted cartridge element inside of it that goes into each cylinder. And then here's another case, the Cirrus on the SR20 gets put into the intake tube. You can't hardly see it, but you can see the wire, how they're running the wire and the fusing arrangement to the plugs. It's really quite simple. You know, the hardest thing is, okay, where do I run that wiring harness? But if you take a look at some of the pictures, you'll see, oh, hey, I can put it in here, putting a cushion clamp right next to the rocker cover, running my fusing right up to the flush mount plug that collects into the side. This is on a D-shaped rocker cover. Here's, again, the SR22 side of the world for a Cirrus install, where it's going into the split rocker cover, and then the ignition leads are following the top of, or the harness leads are following the top of where the ignition leads are at. This is what our pad element looks like. We basically take, and when you buy it, you get the solvent wipe to clean and prep the surface. You put the silicone on it. That is basically Dow Corning 732 clear. We don't want any color because the color is actually an insulator. Take a putty knife, smoothen it up so it's wet. When it's dry, it takes anywhere from 4 to 8 hours to cure, and then just putting silicone around the outside of it to keep any moisture or any oil or anything else that might go on there. And this is what it looks like on the top of the SR22. Here's what it looks like on the side of the sump. The point that we always want to make is we want to see that pad. Opposite side of it has to be oil, so we don't want to be above the oil line. we want to make sure we have our pad location. And you'll see in another slide here where we actually have a threaded element that goes into the sump. We want to make sure that's always the opposite side of it is oil, so we have something that we're heating up on that. This is the what they call cool sump or the crossover manifold. That's where we're starting to use the threaded element or an oil sump screen element to create the heat inside of it, because the bottom of that sump obviously doesn't have oil on the opposite side of it. You've got the intake for it. Last slides I'm going to put through just to say, okay, we have a TANF. How do I know it's working? And what do I do if it's not working? Again, on the installation instructions, you will see all the ohm values and the wattage of all the elements. So you can always ohm it out, whether it be 115 or 230 volts. A real easy way is to use a watt meter, plug it into the wall. Our 4-cylinder system, and I've seen somebody ask that question, what's the amperage draw? It's 240 watts for our 4-cylinder, 460 watts plus or minus 10% for our 6-cylinder system. So if you're thinking now, hey, I don't have electricity, I got to run a generator, a 1,000 watt generator easily runs our system. If you have an inverter generator, it'll easily run it for 8 hours because of the amperage draw. You can just check out our system by using an ohm meter. Put it across the 2 plugs. Again, our installation instructions tell you what the whole system value is. It's all parallel circuit. All of a sudden you see a higher resistance value. Well, now you know that one of the elements is open, because the lower the resistance, the more heat that is produced. So it's a real quick and easy way to check. Here's one that's always alarming. People say, well, I blew the fuse and I got to replace the fuses. And we say, well, we replace the fuses, but get your ohm meter. And when you see 0.4 ohms, you know there's a short someplace. Unplug each connector until that ohm value goes back up into that 50 or 60 range, so you know where you're at, and then you replace that element. I put this in here so that everybody sees what our new fusing arrangement is. It's a little bit more hidden. We used to have a cap that you quarter turned, and a lot of people would bust the tabs off in that cap, so we moved to this more environmentally sealed arrangement. It does say TANF fuses on it, but sometimes it can be hard to see. And we don't only do fixed wing. Like I mentioned at the beginning of the conversation, we do more in the rotor wing and turbine side of the world now than we do in the fixed wing and the piston side. So you don't have to have this type of blast furnace blowing heat into the helicopter. Now they have a generator that's running a couple of the systems that we have in Super Puma. One thing I did want to add to it, some people do ask, well, do you have a means of being able to remotely start your system? I don't want to leave it plugged in all the time because I'm paying for electricity, or I have a twin engine, or I have your preheating system and a big box retailer cabin heater, or maybe we even have our cabin heater. We have a certified cabin heater that can be mounted in there and start spinning your meter a bit. There is a product called Switchion. We manufacture them. We do the assembling in Glenwood. If you go to switchion.ca, you will find that information. It uses the data band of the towers to turn it on with a real easy app. That's very easy. And I'll pop that over because I can't play videos. This was a video over in Glenwood. We had about 5 hours of northern lights here on Labor Day weekend. But I will jump over to the last slide and leave that on there for a while and answer. I think we got probably about 5 minutes, 6 minutes to answer any other questions.
Yes, that was good. There's a few questions in here. I don't know if you know the specific answer to this from a Canadian context, but for the installation, do pilots install that themselves, or is that with a?
So again, I'm not trained in the Canadian side, but our 4 and 6 cylinder systems are STC'd. So the STC allows that install, and then that means you do, at least in the States, means an A&P or an AMO needs to do the install. Experimental or light sport, that's a different ballgame. I can't speak to that from Transport Canada standpoint. It's very, very easy for an individual to do it by following the instructions, but you would have to talk to your AMO find that. I believe every certified aircraft has to be installed by a licensed uh, individual to put our system in.
Roger. Okay, and so what was the next question here? There was one on aircraft, some aircraft being set up with a space heater mounted in the cowling. If you have any comments on the pros or
Sure.
cons to that preheat system?
So, so if you let's just open up the whole amount, what are the various types of preheat systems that are out there? You got forced air, you've got electrical, and the electrical can be also forced air, and the means of gluing or affixing something to it. When you have, like you saw, the great big heater blowing in there, you're blowing air in, and you have to blow so much more heat into it to warm up that oil, because there you're blowing air in, and of course it's leaving at the same time, and it's pulling cool air in with you. So you need a much longer time to do that preheating process. If you are using something that's circulating air, you want to make sure you keep all of the openings closed, so you're not having to heat up that cold air that's ambient. If you can run the air into the cowl and back out through an air force and then go back in, that'll get you the efficiency you want. And we talked about sump only. They work well if you just do them a couple hours before flight, because that'll heat the oil up. That issue there is just to make sure that once you do it, make sure you fly, or pretty soon thereafter, to get the ability of any of that moisture that may have been some other place to get that oil on it and not causing a condensation or a corrosion issue.
Excellent. Anything to add on heating suggestions if hydro isn't available?
If hydro is not available, I'm falling. I'm missing the
I'm not
hydro.
tracking that one. Well, let's follow. Let's come back to that if Gord can expand on that. Let me just go through some questions. Going back to that question on installation, we have Glenn mentioning that he installed his own and his AME signed off on it and did the paperwork.
Yeah, that happens a lot. It's very, very simple to do, and if you have a good relationship, they just need to do the logbook entry. Or here in the States, if you're going to use the STC side, you don't have to install it as an STC. You just need that 337 to be completed, or an engine logbook entry.
Okay, my bad. I should know this.
Hydroelectricity. Okay, thank you. So that we should have thought that one. Yeah. So going back to the wattage used again, 240 watts on the 4-cylinder, 460 watts on the 6-cylinder. So a generator, works very easily. 1,000-watt generator will do it. We do have now people that have used batteries and inverters. So a couple batteries powering an inverter that then turns it to AC, because we need either 115 volts or 230 volts to run that side of it. But many people have use various means off the grid to be able to power it. You don't need a ton of power to heat up that electric one, where if you have to run a 1,500-watt space heater, then that really requires a lot larger.
Okay, that one might haunt me for a little bit, forgetting that. Last question for now. Is there any advantage to having the system on an aircraft in a heated hangar?
So the question there is, how warm are you heating the hangar to? Usually here we're in the Midwest in Minnesota. I run the heated hangar that I have at about 5 degrees C, just above freezing. So then, yes, there is an advantage, again, that getting that little extra on there. If you're keeping it warmer, keeping it up into a higher temperature, then no, you obviously as we all the preheat companies that are in there, we always say our biggest competitor is that dreaded heated hanger, but it's usually quite expensive to have that dreaded heated hanger in place.
Very good. Well, thank you very much for joining us tonight, Doug. Appreciate your support of the program and all the information you're willing to share. Let's take a 5-minute break so everyone can stretch out their legs, grab a tea, and we'll start again at 7:05 Eastern Time. So I'll let you all do the math wherever you are.
Thanks, Sharon.
Thank you. Hello, hello. Hope everyone had a good break. I did receive a question on how to log this into your logbook for recurrent training. So tonight's seminar has been approved for, of course, the 24-month recurrent training as per the CARS. I put it in the chat of specifically what to write down in your logbook. I'm happy to put that up again shortly. You will receive a certificate emailed directly to you, so keep an eye out for that. It's from SimpleCert, so check your junk mail if you don't receive it by next Tuesday. We do give it a few days to actually comb through all the data and make sure that all our information is correct. I'm very excited to now welcome Chris Horson here, who over from Sport Aircraft Canada. I'd love for you to introduce yourself, tell us your flying story, and let's get started.
Sure. Well, thanks for having me, and it's great to be here sharing with you tonight. Sport Aircraft Canada has been around for 20 odd years, and we started out in the brokering market with amateur built aircraft. That was primarily our thing. And then a few years ago, we decided to get into the advanced ultralight market. There were some things that we could do with that we couldn't with amateur built or certified. And so after owning several of those other types, we migrated over to the advanced ultralight category, the light sport category, and then we stumbled on an airplane that we really loved, and we decided we want to be the dealer for that in Canada. And so we hooked up with Skyreach Aircraft out of South Africa, and we brought our first Bushcat to Canada, and we've got a few of them now flying, and under construction as well, because it's now it's also a kit, and we have some kit builders and some other people flying ready to fly versions of that too. And then from there, we've kind of just grown. We've just added a new product to our lineup. We're now also a North American dealer for Shark Aero. If you're not familiar with the name, you might be familiar with the story. The Shark is a plane that has been recently flown around the world by a couple of young people in Europe, and the latest one, he set a record for being the youngest person to do that. And then his older sister, who was I think also one of the youngest people until he did his, is the youngest woman to fly around the world in single engine light sport airplanes. So we're excited to be getting that in a couple of months. It's still in construction right now in Slovakia. And it's actually going to be flown over here by a factory rep. They asked me if I wanted to do that, and I said a resounding no. My wife said no, but we thought that would be an easier way to get it here than shipping it in a container, and with the high cost of shipping these days. So that's kind of where the business comes from. Sport Aircraft Canada is the name of the company. We just launched another branch in the United States called Mach 9 Aero, because we're the dealer for the Shark down there. We wanted to have an American, sort of unique American name for that. And so you can find us online. That website's just getting going, but Sport Aircraft Canada is up and running, and you can check us out there and find contact information and details about our other stuff. We also carry a line of avionics out of Europe. So it's all predominantly geared towards the light sport and experimental market or amateur built market. So it's not certified stuff. It's for the recreational market, and it's been doing very well. So we enjoy doing that too, alongside of our aircraft sales. So why am I talking about aircraft Rotax engines tonight? Because all the aircraft we operate use the 912 series of engines from Rotax. And in fact, the two airplanes we carry are a great comparison of the different types of flying, because the Bushcat is a 90-mile-an-hour airplane. It's a bush plane, as the name implies, and a tail dragger or tricycle, whatever. But it's a rugged kind of fabric and tube airplane. Whereas the Shark is an all-composite carbon fiber airplane with retractable gear and a constant speed prop. And one goes 90 miles an hour, or about 85 knots, and the other one goes 160 knots, and both on the exact same engine. So you can imagine that the operating conditions are vastly different. And so are the requirements for keeping that engine warm in winter months. So that's kind of why we're focusing in a little bit on Rotax tonight, but they are not. The things that we're talking about are not exclusive to Rotax engines, and they'll apply to conventional aircraft engines like Lycomings and Continentals, and even some of the automotive conversions that are out there. So, this again, Doug mentioned that, they recommend that you have your Tannis engine installation done by an AME or an AMP. In our world, that's kind of a gray area because, very often you can do these things yourself and there's no requirements to have anybody certified doing it. But we do highly recommend that you have a maintenance provider who can help you with that, especially if that's not, something you do every day and you're not used to looking after an aircraft engine on a regular basis. Then, it's a good idea to get some help. So just a couple of things about Rotax. No, they are not a sewing machine engine. No, they are not a snowmobile engine. They are a purpose-built aircraft engine. They're built in Austria on an exclusive line, purpose-built for the aviation industry. There's a series of engines now ranging from an 80 horse, which I think might have been discontinued in favor of the 100 horse version, which is a dual carb setup, dry sump. That goes right up to now the 915 engine, which has a turbocharger and is fuel injected, and it's a lot more complex, but also a lot more powerful. And it's now quickly becoming one of the engines of choice. So Rotax has been around for quite a long time. They've got probably over 100,000 engines out there, maybe more by now, that they've built to date. So there's a lot of experience and a lot of the fine tuning of the engine over time. And it's a great little engine if it's cared for. So like any other engine, it needs to be looked after with regular maintenance and monitoring the engine parameters when you're flying, of course. So let me start my presentation here. Let's get that up here. Start. Oops. There, it went away. Somebody was trying to help me. Okay, here we go.
That was me. I'm so sorry.
Okay, thanks. So let's, I've got a little agenda here. We're going to start with we're talking about some of the hazards, some of the stuff Doug's already talked about, but we'll reinforce preheating, engine starting, in-flight information, and then just a quick summary. And if we have time for some questions, I'll try to take some. I'm not an expert on all the technical stuff, but certainly on the operational, it's fairly common sense stuff.
Just before you get started, I'm seeing it loading. Are the slides showing up for you, Chris?
No, they're not. It's showing loading for me too.
Okay, let's try that again then. There we go.
Awesome. Okay, thank you. So let me just switch to the first one there. There's our agenda. By the way, that is a picture of one of our planes. We call it our daily driver. It's a Tecnam Sierra with a Rotax 912 ULS. You can see the two carburetors towards the back of the engine, the two little round things, that's the carburetors. And it has a Tannis heater system installed. So Doug will probably be happy with that. You can see where the probes enter the cylinders. You look at the first cylinder in the front there on the left, you can see where the probe goes into the engine. And interesting to note, Doug mentioned about cylinder head temperature. That is what we call a cylinder head temperature probe area, but actually it's not. The Rotax doesn't really have a cylinder head measurement per se, unless you were to physically install one underneath your spark plug or something like that. Because it has a coolant system in it as well as an oil coolant system. We measure the coolant temperature. So generally speaking, the Rotax has one CHT or coolant temperature measurement, and it looks at the whole, looks at the coolant temperature for the whole engine. Some people will say, oh, well, it has two probes on it. The story about that is that Rotax told me that they put two probes on the engine because some people mount it as a pusher and some people mount it as a tractor. And so you pick the one that suits your use. You don't need to use both of them because they're both monitoring the same coolant system. So if you didn't know that, that's directly from the horse's mouth. So let's move on. Cold weather hazards. I mean, what are the things that can impact us? When we're getting ready to fly, and these are the hazards that we have to deal with. As you know, and what Doug said about oil becomes more resistant to flow when you're cold, and the concern is that the pour point of the oil may be exceeded, and making it the job of the engine oil pump more difficult, so it's not able to push the oil around as easily. So that's one thing. Cold weather increases the possibility of moisture forming in the engine and staying in the engine system. So especially if you don't get your temperature up. So that water can collect in the oil cooler, in the breather, in the oil tank, and it can freeze, and it can not only do damage, but prevent the flow of oil as well, at least temporarily until the engine warms up. But the bigger danger is, of course, corrosion and then freezing and breaking something. Cold weather reduces the capacity of your battery, and that's always a challenge, especially in a small airplane that uses a Rotax engine. It probably has a smaller battery that doesn't have as much capacity as something you might find on a Cessna or a Piper. Fuel, the fuel that we use doesn't vaporize as well in cold weather, so that can hinder the starting process. And it's probably a good point to note that Rotax engines actually prefer MOGAS, not avgas. Avgas can be used, but it has lead in it, and that's a challenge for the Rotax engine over time. It makes it require more preventative maintenance. Inspections happen sooner. So a lot of people try to use MOGAS in their plane, and they try to use it without ethanol. But of course, a lot of fuel these days for cars is now including ethanol, and it's not a no-no for the Rotax, but it's preferred that you don't use it. So if you do use a fuel with ethanol, and obviously that ethanol is a carrier and holder of water, and as it becomes more common, the likelihood of water entering the system, the fuel system, is going to increase, and of course the problems that go along with that. So that kind of fuel also, it's oxygenated fuel, it also burns leaner. So this can be a factor when it's cold out and the air is dense and requires a richer mixture for proper engine operation. So that's something to be aware of when you're buying your fuel and what you expect from your engine in cold weather. So these are some of the hazards. As far as preheating goes, so some of the pitfalls that we note is that, of course, using oil that's not rated for the climate that we're operating in. So a summer weight oil is not going to lubricate well in the winter without a huge amount of preheat. And even after a good preheat and a ground run, the oil temperature can drop below its rated temperature, despite all your gauges being in the green. So it may not be enough just to see green on the panel. You could still end up with an engine engine oil that's too cold to do its job properly. Freezing, as I mentioned, of the moisture that's trapped in the system is a problem, of course, and infrequent operation of your engine or insufficient heat and operating temperatures will allow moisture to gather in the oil system, and then of course we get problems from that. Insufficient preheat. So if we're using a small heater, and I've seen many, especially in the amateur built and the light sport world, where people might not have an insulated hanger, or maybe they're outside and they'll just throw a little space heater with a hose up into the cowling, and they think that's going to do the job. But as you've heard, it does require a significant amount of time to bring an engine up to temperature. And of course, when there's wind or a breeze, that will carry away a lot of the heat unless the engine's really well insulated. And again, Doug mentioned prop covers. We say the same thing. Don't forget to cover your prop, because that is a huge conductor of heat if you have a metal prop, and it's going to pull the heat away from the engine pretty quickly. How long you spend heating up your engine is a big factor. So we keep our airplane in a heated hangar. Doug mentioned 5 degrees. I feel a little guilty because I think we keep ours at about 15 over the coldest months of the winter when we want to fly, and then we go in and top that off with the Tannis heater, usually the day before or the night before, or whatever. We'll turn it on, because even though the hangar might be warm and the airplane might feel kind of toasty, the second we get it outside in the cold, well, it's cooling down again. And by the time we get the engine running and we add fuel and do whatever we've got to do pre-flight, there's a good chance that the engine temperature is already cooled off below, where it's healthy for the engine. So, we think a thorough heating of that engine is important. And remember that the Rotax engine is pretty small. It's not as big as a Lycoming or Continental. And so, it doesn't hold as much heat as those engines do. So it's going to cool off fairly quickly. And even 15 minutes out there could be enough to see your engine drop below a safe operating temperature. Of course, it depends on what the ambient temperature is outside, but chances are if you're flying in January, it's going to be pretty darn cold. So moving right along here, so some of the preheating suggestions that we have, of course, use a preheater that works slow enough to penetrate right to the inner parts of the engine. Doug mentioned that too. You really want to warm up, every part of the engine, not just the surface to the touch. You don't want to do it too quickly because that's not going to penetrate. So you want to allow enough time before your startup for the heater to do its work. So, we say sometimes up to 5 to 8 hours may be required to do it thoroughly, especially if you're not in a heated hangar. You want to make sure you use a heater that's not going to cause damage, to any of the parts on your engine too. So having a heater system like a Tannis is a good idea. It's designed for that. Whereas some kind of a space heater or something that blows hot air may not be designed, for that particular purpose, and you could end up, there's fire hazards, whatever. So we've seen things happen in the past where something's gotten too hot and it's caused a fire and then an aircraft is destroyed. So we want to avoid that. We want to use a heater that heats the case and the cylinders and the oil cooler as well. But also, as Doug mentioned, the oil tank. So the Rotax has a separate oil tank for the oil, and that is a huge place where you can lose heat in the engine. So we have a pad, one of those pads on the side of our oil tank, and so we rely on that to heat up the oil that's in the tank before we go too. So don't neglect that oil tank if you have a dry sump system. It's important to heat that up as well. And in fact, it's not a bad idea to insulate it, but I'll come to some of that in a bit. So we want to heat all parts of the engine, not just the case or the oil cooler or whatever. So the silicone pad and the probe systems are probably the preferred ideal way to heat up a Rotax engine. Use an engine oil cover as well, of course, and the prop cover. Use a winter grade of oil. Now, Rotax generally specifies one grade, but they don't hold you hard and fast to that. So using a winter grade of oil is okay. Synthetic oil is preferred. And just check the specs and the ratings for your climate before you go. And and keep your oil fresh. You don't want to have old oil in there. Rotax specifies 25 hours if you're using MoGas, as low as 25 hours. But if you're using avgas, 25 hours if you're using avgas, 50 hours if you're using MoGas. But it doesn't hurt to cycle out your oil more frequently in the winter, just because of the damage that can occur, in the winter months. So the other thing we do is, and this is where it starts to get, where a user starts to get more involved in how they set up the plane for flight, is blocking the oil cooler off and the radiator for the coolant. So some people will jump in there and just cover the whole thing. Well, that's not a great idea because you don't know what that's going to produce. You end up taking off, and next thing you know, your engine is overheating. So we don't want to necessarily do that. We want to make sure that we take it step by step and find the correct balance of airflow through those coolers versus what you're covering. We generally recommend speed tape, which is like an sticky aluminum foil. You can pull your cowling off and just, we start with 10% coverage and we work up from there until we find a balance of, of temperature for the temperature we're flying in. And we can adjust it. That stuff's cheap. We can just peel it off or add more as needed throughout the winter as the temperatures change, rise and fall. The other method is a cowl flap or a shutter system, which you can control from the cockpit. These work well, but obviously if the manufacturer doesn't build them into the plane, you're kind of on your own if you're going to install something like that. Not necessarily always a great idea to take on those kind of jobs, but that is another way to impede the flow of air through those coolers. So the temporary method we find is usually the best, and that's what we do on our Rotax engines. So engine starting. Cold weather starts. These can be a huge problem for some owners. and some owners have no problems. And so, why is this? Is it the idiosyncrasies of their particular engine, or is it a shortcoming of the operator? It could be both. So some things to consider: if the engine's hard to start in the summer, it's probably going to be even harder to start in the winter. The cold weather is just going to make it worse. So, don't blame the weather in this case. You probably have some kind of system problem that needs to be fixed, and it's a good idea to refer to the troubleshooting manual that comes with your engine. The Rotax has great manuals. There's a lot of it, but they have very comprehensive manuals. And find out what's going on. Talk to your maintenance provider, of course, is a good idea, and see if there's any issues that they can diagnose. The battery, the starter, they're all affected by the cold. So in some cases we say, well, you can use a boost battery to help you get your engine running. But the battery that comes in your plane, if it's a good battery and it's been maintained, then it should be able to do the job in almost any temperature that you would fly in. Some of the more technical things you can do, again, we recommend you involve an AME for this, or some kind of expert maintenance provider for the Rotax engine, and that is reduce your spark plug gap. So by reducing the spark plug gap, you can get a better spark for startup, and that might help you get it running a little easier. But of course, that all depends on the engine being properly maintained overall. So if your engine isn't maintained and you do something like this, it may or may not have any significant impact, because there might be other areas where you've got problems. So sometimes we say, if the spark plug wires, like the ignition wires, are old, or the caps are old, you can replace those things. That's probably going to help a little bit, because as those things get older, they tend to corrode a bit, and the connections are not great. So looking at the grounds in your airplane, making sure all the grounds are perfectly clean and corrosion free, with good, well connected connectors. You want to make sure that there's good connections between all your points. And then, of course, if you still don't have a lot of success, then you may need to fill up with avgas, which might help you start a little easier, by eliminating the alcohol, from the what that comes in the MOGAS. So if you get that out of the system and you use avgas, you might have a little easier time starting your engine. Some of the suggestions for in-flight. I forgot to mention, some of the maintenance stuff, carb setup. The Rotax 912 ULS has 2 carburetors, and there's a starting carb in there. Making sure that is, running optimally is important. So if it's cold, or if your starting carb is not fully engaging, or only one of them is, that can be a problem too. So that's what we call IRMT stuff. So IRMT is a designation you can get from Rotax to allow you to work on your engine. But if you have a maintenance provider, the chances are they'll have an IRMT and they know about that stuff, and they'll know how to set it up properly, balancing the carburetor, making sure all those systems are working properly before the winter comes along. So have a look at that. And by the way, the Rotax takes about 250 RPM to start. So if you've got a battery that isn't doing well, or an ignition system that's not doing well, if it's so cold that your starter doesn't want to turn over, very quickly, then the engine's not going to start unless it can spin fast enough, and that requires 250 RPM on the Rotax. So suggestions for flying: obviously, cold weather flying, maintaining your oil temperature and exceeding the boiling point at least once per flight is paramount. Doug mentioned, a lot about dew point, and alluded to all this stuff. I'm on the more technical side, but what we tell our Rotax operators, they want to get the temperature of the engine up to the point where the moisture is boiling off for at least 30 minutes, in every flight. So in the Rotax, that's about 100 degrees Celsius. They want to get over that for 30 minutes for every flight. If you're not getting to that point, then you need to cover more of your oil cooler, and possibly your water cooler, your coolant cooler radiator as well. The coolant, by the way, is less important. There's no minimum temperature for coolant in the Rotax in flight, so you can just keep that one as simple as possible. But if you're able to block a little bit of it off, that will help. It also helps with cabin heat, because that's typically where most people will draw their cabin heat from, is from the coolant that's circulating throughout the engine. Something you can do to really help with maintaining the temperatures is thermostats. I know some people don't like thermostats. In aircraft engines, they can be a failure point, but there are some good thermostats available for the Rotax engine, and even on the oil side as well as the coolant side, which can help maintain the engine a more consistent temperature and allow the temperature to build up quicker on startup, so that you get your engine warms up quicker, but also your cabin warms up quicker. So having an oil thermostat will help you maintain that minimum oil temperature while you're flying as well. Good idea to keep an eye on it, and probably not a bad idea to keep some spares so that you can replace them maybe after every season. Not necessary, but if you want to have a fresh one in there that's not maybe seized up in some way over the summer, stick one in there, fresh one in there every fall. Again, cover the oil cooler. We talked about that, and the coolant radiator. Experiment with how much you need to cover up, and just increase it a small amount of time until you find that correct balance. Insulate the oil tank if you need to. If your oil tank is if there's a lot of airflow through your cowling, like it is with our Bushcat, has a lot of airflow in it. We found we could help with the temperatures a lot by insulating the oil tank, and that'll go a long way to preserving heat inside the engine. So in summary, be aware of the dangers and how cold weather affects not only your engine, but also how you prepare. We want to make sure that not only our engine is good to go, but that we're dressed properly and we have the necessary resources with us in the plane in case something goes wrong and you get stuck. You don't want to be caught freezing to death. And we say we resist the temptation to just jump in and go, even if you think, oh, well, it's not that cold today. It's like maybe, I don't know, -5 or -10 or something. Take the time, plug the engine in, plug the engines in, and let them heat up. Even if you're that part of that is a warm up on the ground, let it go for a longer period of time to get that engine running properly before you take to the air. If you can, use that heated hangar. I know that's not an option for a lot of people. Hangar storage space right now is at a premium, and heated space probably even more so. But if you can get a heated hangar, that's fantastic for an engine like this. These kinds of airplanes do well. Don't start the engine below -25. That's our recommendation for Rotax engines. Below -25 is probably just too cold to really safely operate it and not do damage. Again, make sure your engine reaches about 100 Celsius for at least 30 minutes in every flight, and this is going to help you boil off any moisture that's in the engine oil. We got to do this, or else we're going to have problems down the road with corrosion. And of course, use that good quality semi or fully synthetic oil that's rated for your climate and that's approved by Rotax or whoever your engine manufacturer is. And lastly, make sure your engine temp is in the green before you go. Don't be tempted to just, it'll heat up when I'm climbing out because, that's full power for whatever. You'd be surprised on a cold day how that doesn't happen. So make sure you're in the green before you leave. That's about it. And if there's any questions now, we can take some questions, and I'll try to answer them. If it's more technical, I might have to get back to you, but go ahead.
Awesome. And I'm not saying I can't read, but if you're using any acronyms out there, please do assist me. That was an excellent presentation. Thanks so much, Chris. There's some good conversation that's happening in the chat here. Well, let's start off with just the most basic one. There was a question earlier on where Sport Aircraft Canada is located. It was answered, but verbally, I'd love for you to just share that information.
Sure. Yeah. We are based, actually my office here in Orangeville is like the office base, but we keep our airplanes at the Brampton Flying Club, which is just outside of Toronto. If you're from another part of the country, we're inside of Toronto's control zone. That's where we are based. Mach 9 Aero is in DeLand, Florida. That's our US branch.
Nice. And so there's a question on or if you could speak more towards testing for ethanol.
Yeah, so that's a great question because that's come up this year for the first time in my entire Rotax experience. And I'll tell you, there's nothing like a hesitating engine to grab your attention when there's water in your fuel. And so we went out, and you can get these things on Amazon. They're not cheap, and all it is a plastic container. But there's a test kit you can get, and it's about 25 bucks, and you fill it part way up with water, I think, and then you fill it the rest of the way up with fuel, shake it up, and leave it. And if you come back and that water line is different than it was when you started, you know that there's more water in the fuel, something to that effect. So that's just one type. There's a number of types. You can also use a hydrometer, I think it is the right tool, if that's the right word, to measure the density of the fuel, and you can discover if there's water in it that way too. But super important to keep an eye on that. And another reason that came up this year is because one of my colleagues who runs a flight school that uses a Rotax engine, a Rotax powered airplane, he had some challenges with his engine, and they discovered that despite the fact that the fuel distributor, I won't mention the name of who that was, but despite the fact that on their pump it said ethanol free, it turned out to not be ethanol free. And I don't know if that was a mistake or if that was deliberate or whatever, but it just goes to show that you can't necessarily trust what's on the sticker on the pump. So from now on, like our policy is now we test all our fuel for ethanol. We want to make sure we know if that's actually in there or not. Obviously we want to get what we paid for, but it's a good idea to know if it's in there or not, and be prepared for whatever might become of that. In his case, it was an engine out, so yeah, don't want to have that happen.
So someone made a comment here, and I'm wondering if you have thoughts on it, in how MoGas or regular gas goes bad fast nowadays, not like it used to be. I don't know if that's accurate or not. Do you have any thoughts on that?
Yep, the general consensus is that MoGas does not last nearly as long as avgas. We buy fuel literally from the pumps every time we fly, and we bring it in and fuel up our plane. We do not store fuel for any length of time, except for what's in the plane. And I usually try to be adding new fuel to what's in the tanks when I go, just to get as fresh as possible in there. And then, so if I have flown the plane in a few months, what I will often do is I will drain it all out and stick it in my lawn tractor and go get new fuel for the airplane. So we don't like to keep fuel. 3 months is about the limit, but that's probably even pushing it.
Okay. I should mention for the testing answer that you had given earlier, someone had mentioned you can buy it off Aircraft Spruce as well. So
You
little
can.
plug for them.
Yeah.
Oh no, I just lost my question. There was a question earlier on if it's recommended to use 100 low lead.
Well, you can. You can use avgas in a Rotax engine. It is approved. The challenge is that the lead accumulates, and I'll tell you where you see this. So, for example, we started with avgas in our first bush cat, and we went to do the first oil change, and I decided to look in the tank instead of just draining, opening the drain plug on the bottom. We opened up the tank from the top and took the screen out, and on the bottom of the tank, there was a pretty big accumulation of this lead sludge. And so, of course, we take the whole tank out, clean it out, and put it back together. But that same sludge is accumulating in other parts of the engine. And one of the biggies is in the gearbox. So the Rotax engine has a gearbox on it, a gearbox reduction drive. And typically you can go, I think it's 800 to 1,000 hours before you inspect that and tear it down. But with avgas, you need to go, I think about 600 hours is the requirement. So you have to do it sooner, and that costs money. So if you want to save some money and extend the life of your engine, avgas isn't necessarily the way to do it.
Great. There was mention of using food coloring for the testing. Is that advised? Seems like a Very low
I'm not
cost.
familiar with that test. If somebody wants to share details on the chat group, I'd be interested to hear about that, but that's not one I've heard of.
Okay, I'll just bring it down to two last questions here. There was a question earlier on the bush cat if they have heat in the cabin.
Yes, we do. We circulate coolant through the cabin, and we have a couple of electric fans, one on either side behind the panel. And there's a switch, and you turn the switch on, and it just blows the heat from that cooler down into the footwell. It does a pretty good job, but we always say dress warmly.
Dress warmly. Important advice. Okay, last question here is it's more on sharks. How is a light sport plane like the Shark registered in Canada? So
That's
advanced
a great question.
ultralight, certified, or home built? Pardon me for
Well,
interrupting you.
okay, I'm going to take this hat off and put on another hat now because I'm part of the Canadian the Transport Canada Safety Campaign and some of those working groups, and so this gives me access to people with lots of different kinds of information. And one of the things we learned in the process of bringing the Shark to Canada was that the rules for advanced ultralights changed about a year or so ago, and nobody really said much about it because it wasn't a direct impact on the design standard, which is DS 10141 for advanced ultralight aircraft in Canada. And what they did was, we've always said, oh, there's no speed limit on airplanes on advanced ultralight airplanes in Canada, but in fact there is, and it's 150 miles per hour. If you went beyond that speed, there was another definition that you could use to qualify the plane as an advanced ultralight. Well, what Transport did was they removed that other definition. So if you want to bring an airplane in that's fast now, that definition is gone. You can no longer bring it in. I believe the VL3 by JMB was the last airplane to qualify using that alternative definition. It's a pretty high performance airplane. It has the same kind of retractable gear and constant speed prop, and a busy panel with lots of technology in there. We don't feel like that may be the best option for somebody with an ultralight pilot permit necessarily, depending on what their background in flying is. But if you're a beginner, those are not beginner airplanes. And so Transport, I guess, agreed with that and decided to take that definition out to prevent those planes from getting in there. So now a plane like the Bushcat or a plane like the Shark and anything like it in the future has to come in as it's basically special C of A limited. So it'll come in. The limitation is that you'll have to get it maintained by an AME. You can't maintain it yourself anymore. You can do some of the maintenance like you would with any other certified airplane, but then you have to have an annual inspection done by an AME. Other than that, there's no real limitations to what you can do with it. It's just another airplane. So no more advanced ultralight for the high performance stuff.
Very informative. I think that we'll need to have you back in the future because we could probably add a few more topics, especially as it relates to the to TC's General Aviation safety committees. So thank you very much for that, Chris. I appreciate and COPA, the entire team at COPA appreciates your time here with us tonight. Let's switch over to our last presentation of the evening on search and rescue. And then we'll close out the seminar. So this content comes directly from a project with Casera and through Smart Pilot. And we have Ronan Court here. So hey, Ronan, thanks
Hi.
for joining us. I welcome you to introduce yourself and tell the COPA community a little bit more about yourself.
Yeah, so my name's Ronan. I'm a flight instructor candidate. I come from Calgary, Alberta, but I'm currently living out in the lower mainland of British Columbia. I've been flying for 5 years and kind of raising awareness about search and rescue and survival training is something I'm super passionate about. When I was in grade 12, I was fortunate enough to get the opportunity to facilitate a survival course and had some great sponsorship from Lightspeed on that. So I am looking at hosting another one of those in the next couple of years. But until then, stuff like this webinar series is great to raise awareness on survival. So thanks for pulling up the presentation there, Sharon. We'll just get right into it. So out of the millions and millions of general aviation flights every year, only a handful end in an off-airport landing. And even though the consequences or the likelihood of experiencing one is quite slim, the consequences can be fatal. There's many sayings, we all know lots of sayings in aviation, but one of my favorites is this one right here, that your engine doesn't know what it's over. It can quit at the worst possible time over the worst possible terrain in the worst possible weather. But no matter where it happens, you can almost guarantee that there isn't going to be a search and rescue team waiting for you at the scene of the crash. So on that topic of unforgiving terrain, would you be willing to spend a night out in this forest without being prepared for it? This is exactly where you could end up after a forced landing. And the goal of this presentation is to start getting you in the mindset of preparing for it. So throughout this presentation, we're going to have two themes. The first one being what it takes to survive a forced landing and the time that you'll have to wait for search and rescue. And the second being how to alert search and rescue and how to help them actively find you. So surviving starts with preparation, which starts the second that you start thinking about flying. And as a pilot, part of your job is to be prepared not only to deal with the in-flight emergencies, but to also deal with the consequences of this off-airport landing. And this means two things. First, doing whatever you can to make sure that you're found quickly. And second, having the knowledge and equipment necessary to help you and your passengers survive while you wait for the rescue. So let's look at what that preparation entails. To start, how are you and your aircraft equipped to survive? You should start by putting together a survival kit to keep in your aircraft. The cars are pretty clear on what you need to carry in this kit. You need sufficient gear for each person on board to survive in the given area and weather conditions, including means to start fire, provide shelter and water, and visually signal distress. When you're building this kit, think about who you're flying with, where you're flying, and what time of year it is. And as you're building this kit, think about items that can be used for many tasks. Something like these old coffee containers could be used as either the pot or the stove to contain the fire. Stuff like a good metal water bottle can be used to both transport water and boil it so it's safe to drink. It's all too easy to put together this kit and totally forget about what's in it and go to open it in the middle of the forest and realize your headlamp's dead or you've taken a lighter out and forgot to replace it. To avoid this, try and inspect your kit on a regular schedule. It's a great time to do it in your annual. Personally, I like to do it in my quarterly, and that gives me a time to change the contents of my kit based on the season. I don't need a snowsuit in the middle of July in Alberta. With that said, you should adapt your kit to specific flights. So taking that snowsuit, for example, in the middle of July, if I'm flying over glaciers, I might want to take that snowsuit. But if I'm flying to Saskatchewan in the middle of July from Calgary, I probably won't need it. Part of survival preparation is being mentally ready, personally ready. There's many resources out there, but the best one you can take is a survival course. These courses give you some basic understanding of survival techniques and resources. We should have some more information on that on our website, smartpilot.ca. If you can't find a survival course in your area, find a backpacking course. Most retail stores like Mech or Atmosphere, they provide these courses on a pretty regular schedule. And although they aren't survival focused, they should give you some really great basic outdoor skills. Now, remember that first aid kits are also legally required on board your aircraft. Now, a prepackaged, off-the-shelf survival kit is certainly better than nothing, but you can, again, build your own. Again, Transport Canada regulates what you can carry inside that kit, and that's all outlined in the aviation occupational health and safety regulations. So during the forced landing, you can expect significant physical trauma from sudden deceleration, serious lacerations, and burns as a result of post-crash fire. Also expect psychological trauma, particularly if passengers have been harmed in the crash. Physical injuries can also occur after the crash, with potential cuts from a knife or axe, burns due to fire or boiling water, or even eye injuries from branches. Think about trying to cook Thanksgiving dinner after having only a couple hours of sleep over the last few days. You're bound to have an accident with some hot water or a sharp knife. You can, like I said, assemble your own first aid kit, but it's also important to periodically inspect these. Things like alcohol swabs can dry out and medications can expire. And do this on a schedule that makes sense to you. You can do it during your annual, do it quarterly, whatever makes sense for you. Consider taking a first aid course too. The Red Cross is a perfect place to start, though local organizations often offer them as well, and they're usually short enough that you can get them done in a weekend. It's also important to have something that will help you get out of your aircraft if the doors have jammed. This could be something like an axe or a hatchet. Make sure it's both accessible for quick access and egress, but make sure it's secure. You don't want this flying up and hitting you in the head the second you hit turbulence. If you fly a canopied aircraft, consider buying a off-the-shelf pry tool, something that could break the canopy. If you aren't in a canopy aircraft, something like this could help you break through the windshield or side windows if your doors have jammed. A seatbelt cutter is a must-have in your aircraft. Just again, remember to keep it somewhere within arm's reach. Maybe you could Velcro it up on your dash or tuck it in a side pocket. Personally, I carry a knife with a belt cutter and a glass punch all in one, and I keep it in my kneeboard pouch or in my headset case for quick access. Now, keeping with that theme that your engine doesn't know what it's over, remember you might have to execute that forced landing procedure over water. A takeoff or landing over water or flight over water in any case might have to mean that you get out of a sinking aircraft. To be clear, if you're operating your float plane from the water or land plane beyond gliding distance of shore, a life preserver, individual flotation device, or personal flotation device must be carried on board. Ensuring you're rescued in a timely manner also depends on your ability to successfully alert help about your emergency. And that starts with the alerting systems that you carry on board. Legally, your aircraft should have a ELT, emergency location transponder, unless you operate a glider, balloon, airship, ultralight, or gyroplane. Now, as Chris had said earlier, ultralights have come a long way. They've increased their cruise speed. They've become a bit more capable than they have been in the past. So just because you don't need ELT doesn't mean you shouldn't have one. Why are my slides changing? There they go. Some aircraft are still flying with the 121.5 megahertz ELT. These haven't been monitored by satellite since 2009, so not many are listening for them. With that being said, the airliners flying up in the flight levels will usually be listening to 121.5 and relay any signal they have heard to air traffic services. This is also great motivation for you guys to be listening to 121.5 if you're on a long cross country, especially in mountainous regions or regions where there aren't many aircraft. Just because you're not in an urgent situation doesn't mean that you can't help someone else out. Those search and rescue satellites are now listening for ELTs broadcasting on 406 megahertz, commonly referred to as 406 ELTs. A properly registered 406 ELT will provide for search and rescue with your aircraft details and emergency contacts relayed to Joint Rescue Coordination Centers. This will help confirm your emergency and launch search and rescue services quickly. So Adrian showed a great slide on that ForeFlight presentation of the circle search. And what a 406 ELT does is it tightens that circle just 2 satellite pings, and it has an accurate pinpoint of your location. Most ELTs come with a panel-mounted switch, and these allow you to activate your ELT even sooner, even before you touch down, just helping search and rescue get to you sooner. The key to having this search and rescue system work best for you is to have your ELT registered with the proper information. Keep the registration and the emergency contact information up to date, and you can do this all through the Canadian Beacon Registry. Now, separate from ELTs, there are other systems that can complement the ELT. They can't replace it, but they can definitely complement it. One of these is the PLB, or Personal Locator Beacon. These are quite economical and very portable. They're quite easy to put in your pocket or in your side pocket of the plane. These are also registered, but not with the Beacon Registry. So when you register it, make sure to indicate that it's carried on board an aircraft. Now, cell phones can also be useful, but only if you have cell service. When you're flying, you might find that your phone tends to die a bit faster, and that's because it's constantly searching for cell towers. So try to keep it plugged in during the flight. Personally, I have a rule with myself that I don't let my phone get below 80% when I'm flying. Devices like Spot or Garmin InReach, they're connected to a private alerting services. So if you use your Spot, include a note that is carried on board the aircraft in that comments box on the registration, and include a Joint Rescue Coordination Center in your contacts. Those numbers can be found in the AIM. Spot and InReach also provide breadcrumbs on a full service plan with annual fees. But these breadcrumbs can be laid at an interval of 2 minutes or less. Satellite phones are another fantastic tool to use in remote areas without cell coverage or little cell coverage. Now, if you have a well thought through survival kit and a first aid kit, and you have all the alerting systems working for you, the next step is planning to survive every time you fly. And this begins with the route that you choose to travel. So if we look at this map here, it looks like we're heading into Spokane from Sandpoint. And the direct route is going to take us over some pretty high mountainous terrain. But if we were to follow the highway, we'd have a lot more suitable areas to land. But also once we land, emergency services are able to access us quicker. Stuff like fire and EMS and even bystanders would be almost right there. Versus on top of the mountain. What do you guys think is more important in a survival situation, food or water? I'll give you guys a second to answer in the chat. Yeah, I'm starting to see the answers roll in here, and so far everyone's right. It's water. Current studies are showing that you can go almost a month without food, but only 2 to 4 days without water, which is kind of in line with the fact that that 3-3 rule that we've all heard about. But before we leave the you can't live without food issue, keep in mind that you can live without food, and few people die of starvation. But not having food will create its own set of problems, including but not limited to fatigue and low blood sugar. If you don't have food, or if you have very little food, do all the hard work early and pace yourself, knowing that your body's about to start to dig into its fat and muscle stores for energy. Now, how much water do you actually need in a day? Current studies show that you need 2 to 3 liters a day, and that is water of all sorts, water through a bottle or water that you find in your food. You use this water at an astronomical rate. Just breathing expels a liter of water per day. Keep in mind that your need for water is ongoing. So if you start to feel dehydrated, that's just going to build up. And eventually, you're going to get to a critical point and you're going to start to have problems. That so-called dead in 3 days without water situation is one where you aren't getting any water at all. Don't ration water in a survival situation. Instead, ration your sweat. You want to stay hydrated as much as possible. So you can reduce the amount that you're sweating by doing the harder work in the cooler part of the days, or doing all the work in the cooler part of the days. Don't work in the peak heat periods where you're bound to sweat more. Now, your body needs water more than it needs food. So if you're short on water, minimize your eating, since you need water to aid in digestion. And if you are going to eat, avoid the protein and fat. Eat the carbs first, as they need less water to digest. Now, before you run out of water, have a plan to get more. There's many ways that you can get water, aside from the obvious finding a river or melting snow. You could tie fabric or cloth around your ankles and walk through wet underbrush to collect condensation. Or you could tie a plastic bag around the end of a tree branch. And if you have a long day, the energy from the sun will take all the water out of the leaves and needles and can put it in that bag. You can go forage for food in a survival situation, but if you aren't certain about it, don't eat it. I feel like that goes without saying, but you never know. If any of you remember the book Into the Wild, it kind of went over the dangers of foraging for plants and fungi and all that good stuff. Many of the edibles that you find in the forest or in the wild might look like they're of the non-poisonous variety, but there's many that look like they are. So a better idea than foraging is to have food in your survival kit. Stuff like dehydrated food packs, that backpacker's pantry. Having those and a way to cook it is invaluable. Dehydrated foods are lightweight, easy to cook, and take up very little room in the kit, and they usually taste better than the handful of berries off the tree. Again, thinking about who you're flying with in that preparation stage. If they have allergies, maybe they can't eat the prepackaged meal. In that case, try and find an alternate. Maybe pack a couple extra granola bars in your flight bag. So before we say goodbye for the night, I know you guys have been here. We're approaching the 2-hour mark. So before we say goodbye, I just want to highlight a few key things. You want to make yourself easy to find, not just on the ground, but before you even leave the ground. You should have the proper alerting systems functional and know how to use them. Always prepare yourself and your aircraft and passengers for the worst case scenario, taking into consideration the terrain and the environment you're flying over, not the environment you're flying to. If you're flying to Hawaii in a single engine aircraft, please don't wear shorts. Wear and pack the proper clothing and equipment so you can survive until help arrives. Although the temptation may be there, don't venture away from the aircraft. Remember that the spotters are looking for your aircraft. But aside from that, there are things in your aircraft that can help you. If the aircraft is in a safe position, as long as it's not hanging from a tree or on fire or anything, you can use the aircraft for shelter. There might be things in the aircraft that'll help you in this survival situation. Things like wing covers or cowl covers make great blankets or tarps. And the fuel that's left in the wings will definitely help you start a fire. If you can bring water, do. You don't need a whole lot of water, but if you don't have a lot of water, make sure you understand how to collect it. Try and ration the water. Don't ration the water, and try to find other sources while you're using the water so you can keep hydrating yourself. Attitude is everything in this survival situation. A crash can be a very traumatic experience, especially if you have loved ones who have been injured in the crash. Just remember that the end goal is to survive and live through it, and keep working towards that. There'll be time to grieve upon the rescue, but until then, keep working, keep a positive frame of mind. Do everything you can ahead of time to prepare for the forced landing. You don't want to be behind the plane. Remember, we've all heard it at some point or another during our career. Stay ahead of the plane. Ensure that you have a survival kit that includes what you and your passengers will need to survive in the wilderness and alert others. Make sure you have a good first aid kit and inspect both on a regular basis. And I love that comment from Warwick right there. Think about what you put your survival kit in. Don't take a tub to carry through the forest. Download whatever survival information you can to your phone and tablet, information that can be helpful during a crash. I saw a recommendation from a book, Down But Not Out. So you can download it to a device. We all use for flight. We all have iPads, phones on board. But another great way to do it is just print it off and put it in the kit. Also, make passenger briefing cards. You might not have to do the whole flight attendant briefing, but once the passengers read it and they've used it, and you're in the survival situation, that extra paper will help you start a fire. At the very least, take a basic first aid and survival course. They'll give you some great practice and know-how, lots of skills to use in the survival situation. The key to living through all these survival situations that we've talked about is preparation. Okay, you need to prepare to survive, and you need to prepare to alert the search and rescue teams. If you are failing to prepare for the forced landing, you're preparing to fail. And that's all I have for you guys tonight. I think we've just crossed the 2-hour mark. Thanks so much, Sharon, for letting me come and talk about this. I really appreciate it.
Hey, that was great. Thanks so much, Ronan. There's not many questions in the chat, more of just solid information sharing. So and that's what this community is all about, right? So why don't I just read some of them? I know you already had one mention from Phil Lightstone. Hey, Phil. Phil's been a speaker for some of our seminars here, and he raised a good point on how PLBs are registered with the Beacon registry and personal locating devices are registered with third parties. And he had just mentioned that oh no, there's a lot of new messages coming in. The PLDs they offer two communications over satellite, and that's obviously it makes us feel a little bit safer. One of our program sponsors, Zolio, would be considered a PLD, I suppose, and I use it mostly for camping, and you can have them text. There's all kinds of benefits for these devices, so that's great. So lots of appreciation here and some echoing of dressing for not for the flight, but for the forced landing. Okay, so we've gone through a lot tonight together. Let's continue on. At the start of the seminar, I had mentioned that we do give away an annual prize simply to our members for participating. And of course, these seminars, we want you to meet the requirements for recurrent training, but we hope that you're here and we see that you're here simply to improve your understanding, your familiarity on a subject matter. So we want to continue building on that culture of safety. So the first prize, which was a Lightspeed headset, a Sirius XM Pilot Pro package, and a few other goodies. That I had run it through our system, so it wasn't any names being picked out of a hat. That would take me all night. We're all about efficiency here. The prize winner for that goes to Bob Gillis, who is actually a COPA flight captain for our chapter out in Miramichi, COPA Flight 39. So that's nice to see. And I know that your group has been doing a few viewings together. So congratulations to Bob for winning that awesome package. And then the second prize goes out to Dan Lauren out in Ontario here, and that prize included a Sirius XM package as well as a new COPA membership renewal. And I should mention the first prize, it came with a nice donation from Lost Aviator Coffee. So that was great. Lots of thank yous in the chat right here. So I appreciate everyone for coming. It is the last safety seminar of the year. And Jim Ferrier had alluded to it in our last seminar. We're not quite ready to share the news yet, so we're going to extend that tease. But a lot of good things are coming in 2023. We did put out a survey last seminar of the topics that interest you most. One of them was flying out in BC and Alberta. So that we'll continue on with that, but some good changes are occurring, and we appreciate you for being with us here tonight. Chris, you were very informative. Appreciate your presentation. Doug, thank you for your time and all your support of the program, and your willingness to always be at our COPA events. And Ronan, appreciate you jumping in with the SAR training. So thank you, everybody, and have a great night. Bye.